Intensive and dynamic research on palm oil pollution abatement has paid off efficaciously, and the Malaysia palm oil industry is leading the trend towards sustainable palm oil production. As a roadmap to palm oil zero emissions, palm oil polishing should be accomplished either for water reclamation, reuse, or absolute pollution abatement. Apart from the recognized problems such as not being cost-effective and system inconsistency, a polishing tertiary treatment technology which exhibits reliable, sustainable, and affordable features is most awaited. Activated carbon from biomass are alternative adsorbents for the industrial sector. It is popular because of its well-known efficiency for the removal of pollutants and heavy metals in wastewater treatments, abundance raw material, low price, and ease of use. Activated carbon from all palm biomass are therefore considered as environmentally sustainable and economically viable. All palm biomass are generated from the mill and are available at the mill site. Owing to these advantages, the raw material, transportation, and operating costs can be minimized. Palm kernel shell is a suitable precursor for activated carbon production due to its high density, high carbon content, and low ash content. Activated carbon from palm kernel shell can be produced by carbonizing the biomass at temperature below 500 degrees Celsius and to convert to biochar, activate at high temperature of above 800 degrees Celsius through physical or chemical activation methods. The 2-in-1 carbonization activation system was developed to improve production efficiency by combining the separate processes of carbonization and activation into a single system. The 2-in-1 carbonization activation system has been patented as a state-of-the-art technology for carbonizing all palm biomass and simultaneously producing activated biochar carbon from all palm biomass using a self-sustained system. The treatment of palm oil mid-effluent final discharge using activated carbon palm kernel shell has been tested on a continuous pilot-scale plant, resulting in a great reduction of pollutants in palm final discharge. The continuous adsorption systems relates to a concept of a green process without the use of chemicals for palm final discharge treatment, comprising two important principles. The first one, pre-treatment by a biological method using extended aeration activated sludge process, and secondly by activated carbon process. The green process for palm final discharge treatment comprises the following steps. First one, production of activated carbon of palm kernel shell using the physical activation method. Secondly, biological treatment method using effective microbes in activated sludge process. Thirdly, physical chemical absorption on the activated carbon treatment process. Fourthly, treated palm final discharge used as a recycled water for the backwash of sand filtration and activated carbon column. And finally, spent activated carbon can be reactivated or used as an organic fertilizer for vegetative plants as it contains beneficial enriched nutrients such as nitrogen, phosphorus, and potassium from the adsorption of palm final discharge. A novel integrated system comprising an activated sludge process with suspended packing system and bioadsorption system in series was developed for palm final discharge treatment. Almost 100% of biological oxygen demand, chemical oxygen demand, total suspended solid, and molecular nitrogen and color could be removed during the first 24 hours, producing clear water and almost 90% removal throughout the process. The activated sludge process with suspended packing system mainly contributes to the reduction of biological oxygen demand, chemical oxygen demand, and suspended solids sand filtration, while activated carbon is mainly responsible for the high removal of pollutants and color through physical chemical adsorption, as well as enrichment of the spent activated carbon by adsorption of the nutrients in pome. The estimated cost to build up the continuous adsorption system with a capacity of 50 m3 per hour is 350,000 ringgit. The net present value at a 10% discount rate is 260,836 ringgit. A profitability index of greater than 1, which is 1.62, and an internal rate of return of 23% can be achieved. Therefore, the investment is expected to be financially feasible. The installation of the proposed integrated system will be more profitable in the long run installed by the palm oil millers, where the electricity is generated from the energy and steam released during the carbonization of palm kernel shell. Revenue can be generated from the biofertilizer, spent activated carbon, and treated water such as recycled water for wet scrubber or cooling tower.